This is lesson 5.6, elementary algebra, and the name of this section is called binomial squares and other special products. So let's go ahead and just get started with some examples. You don't really need to know all of the vocabulary here before we get started. And the first example says find the square of 3x minus 2. And what that means is it says find the square. That means we're going to square the entire thing. And when we square like that, all that means is we are taking 3x minus 2 and multiplying it by 3x minus 2. We're doing it twice. Okay? So then we can just use the FOIL method and go ahead and solve this. So the first terms, the outside, the inside, and the last. And then again, we can combine those. And get that for an answer. Okay, so that's what it means when it says find the square. Alright, so let's look at one that is lacking all numbers and just has some letters in it. Let's look at one like a plus b, the quantity squared. So again, we're just going to write it as a plus b, parenthesis, times a plus b, parenthesis. So, first, outside, multiply a times b and you get ab. Multiply b times a and you also get ab or ba, but I like to write it alphabetical. Last, you get b squared. Now we can again combine these. And when we have one ab and we add a second ab, we have two ab's. Okay. The other example, 2b, has a minus b, the quantity squared. So again, we'll do the exact same thing, only we've got that negative there. First term multiplied, outside, inside, last. I can combine these. Okay, and I get that. All right, let's look at just real quickly what happens when we have two numbers that are squared like that. Okay, a plus b, the quantity squared. You can do the work, FOIL method, yada, 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 all the way here. Or you can very quickly look at this and say, all right, what if I have x plus 3 and I'm squaring it? What happened up here for a plus b, the quantity squared, in our answer? The first term in our answer was squared. So if we write our first term squared, all right, what else do we have? We have a 2ab. So that means our first term times our second term doubled gave us this one. So if we look at this bottom one, we'd be going first term times the second term, 3x, and then double it. Multiply it by 2. And what happens to the last term? It's squared. So if we take our term there and square it, so we're going to take our last term, 3, and square it. So we get x squared plus 6x plus 9. And we didn't have to really go through this whole FOIL method. Now you can. It works either way, and if you feel more comfortable doing the FOIL method, that's fine. But the rule is first term squared, second term squared. So first term squared, second term squared. The middle term here is this times this, and then doubled. So 3 times x is 3x, and double the 3x, and it gives you 6x. All right, the same works when we have something like a minus, like we do on the right-hand side. So for example, we have x minus 5, quantity squared. Going to do the same thing. First term squared, second term squared. Okay, negative 5 times negative 5 is positive 25. Okay, middle term will be this times this, negative 5 times x, doubled. Okay, so x squared, 2 times negative 5 is negative 10 plus 25. Okay, and that's what you end up getting. The only part that gets to be a little tricky is that doggone negative there. So let's go ahead and do a couple more of these. And like I say, if you decide that you just want to do the FOIL method, that is fine. This is just a little bit of a shortcut for those that want to do that. Let's look at 2x minus 3y quantity squared. Alright, so the rule is square the first term, square the last term. The middle term is this times this, which is negative 6xy times 2. Okay, so what would help me if I was learning this, if I just put plus signs for both of these, I'm going to be safe. Because when this sign here does become negative, this 2 times negative 6, which gives me a negative 12, that will replace that plus sign. So I think that's probably the easiest, is just put a plus sign there. So then when you multiply plus 2 times negative 6, then you get that. Okay. All right, let's look at one more here. And this is the last one of the examples, top of page 362. And it has 5x squared minus 4 quantity squared. Okay, first term squared. Okay, so if I'm squaring that, that means it's actually let me show it written here. 5x squared. We square the first term, which means 25x to the fourth, right? Square the second term. And if you remember, for the middle, you multiply those two and double it. Okay, so there I have a plus sign, there I have a plus sign. So we get 25x to the fourth minus 40x squared plus 16. Now if we would have done the FOIL method with this and written this as 5x squared minus 4 times 5x squared minus 4, we would have gotten the same thing. It just depends on if you want to learn some tricks of the trade to kind of save you some time. But again, if it's too confusing to learn yet one more math trick, don't worry about it. Just learn how to do it and practice it in this assignment. Next section here is called the difference of squares. And sometimes you'll have a problem that looks like this. Now notice, the numbers are exactly the same. Whoops, sorry about that. I have a 7 there for some reason. Let's make it a 3. Okay, so numbers are exactly the same. If I can make it a readable 3. All right. The only difference is this is a minus and that's a plus. So when that happens, okay, you can use the FOIL method, and you will do the first and get 4x squared outside, inside, last. These two middle terms, a positive 6x minus 6x is 0, so you end up with that for an answer. Okay, so here's the trick for these. When you have the exact same numbers, the only difference is one's a negative, one's a positive. Square the first term, 4x squared. Square the last term, 9, and put a minus sign. Always a minus sign. It will never be, well, what if this is a plus and this is a minus, or this is a plus and this? If the signs are different here, it will always be a minus sign. And that is called the difference of two squares. Now, where they get the difference of two squares, we will learn later. Right now, I'm just wanting you to learn how to do it. So if we have something like x minus 5 times x plus 5, square the first term, square the second term, put a minus sign. You're done. if I have 3x minus 1, 3x plus 1, square the first term, square the second term, put a minus sign. Okay? So the middle term always goes away when you're using the difference of squares. So that makes it real easy. So let's look at some of the examples down at the bottom of page 362. I'm not going to worry about 10 or 11. Let's do 12. 1 plus 9a times 1 minus 9a. Okay, so remember, square the first term, square the second term, put a minus. 2x minus 5y. Again, we're just doing another example here. And we'll just do it to the right here. Square the first term, square the second term, put a minus sign. And let's do one more. This is number 14. 3a squared minus 7b squared times 3a squared minus 7b squared. Alright, so the rule is the same. Square the first term. So 3a squared, so square the first term, looks like that. This 2, remember, is on the 3 and on the a squared. So it's 9, 3 times 3. A squared, this means multiply. Then we do the 7b and the 7b. And that looks like squaring that. So we square the 7, and we square the b squared, which is b to the 4th, and again, always a minus sign there. And we get that for an answer. And that is pretty much it. If we look at a last example here, which would be example 15, we've got a story problem. Write an expression in symbols for the sum of the squares of 3 consecutive even integers. Okay, 3 consecutive even integers. Remember, consecutive even integers are going to look like this. So it's like if this one was 2, this one would be 4, that one would be 6. Or if this one was 8, this would be 10, this would be 12. Okay, so those are the consecutive even integers. So those are your 3 consecutive even integers. Write an expression in symbols for the sum, which means we're going to add those. Okay? But we're not only adding them, it says write this expression in symbols for the sum of the squares. So we're going to square each one of these. Alright, so x squared plus, if we're going to square that one right there, x squared plus 2, what are we going to do? We are going to square the first term, square the second term, multiply x times 2, and then double it. Oops. Okay, so there's my x times 2, and then I doubled it. Let's do the same thing up here. Do this in green. Square the first term, square the second term, plus, multiply 4 times x, and double it. So let's go ahead and work through this. Okay, combine like terms. So I have 3 of my x squareds. I have a 4x and an 8x. I have a 4 and a 16. Okay, and that's what they're asking for when they said simplify it. Okay, all right, so that's it for 5.6.